duplicates from sorted array? This is an easy question. So for doing that, we have an integer array nums, and it's in non-decreasing order, and it is sorted. And we should remove duplicates in place such that each unique element appears only once. The relative order of the elements should be kept the same, and we are going to return k after placing final result in the first k slot of nums. So let's go through an example. In this example, as you see, we have a sorted array. It is increasing order, and we have a duplicate element here. So what we're going to return is going to be a sorted array in the same order, but with unique elements, and we don't care about the end of the array. So as long as we have all the elements, all the unique elements from the list in the same order that they were in the list, and at the beginning of the array, so we don't care about the end of the array. We can put them at the end, we can move this one at the end, and all we care is about having unique elements in the sorted order at the beginning of the array. And what we are going to return, we are going to return the number of unique elements. So as you see in another example that we have here, we have 2 zeros, we have 3 ones, but we are going to return all the unique elements in the same order that they were in the list, and at the beginning of the array, and we don't care about the end. We can move all the duplicates to the end of the array. And what we are going to return, we are going to return the length of the unique elements that we have in the array. So let's see how we can do that. Let's go through an example. For solving this problem, we are going to use 2 pointers. And how can we do that? Let's say this is the array that we have, right? So we have 0, 0, 1, 1, and we have 2, and we have 3. This is the array that we have. We are going to use 2 pointers. One pointer is pointing to index the first index, and the second one is going to point at index 1 as well. So this is how we started, and we start iterating over this array and see if the element that the pointer I is pointing at is smaller than the element that is before p pointer here. We check if the one that I is pointing at is bigger than the element before p pointer. So let's go through this example so you can better understand. So we start iterating over this array. So 0 is not bigger than 0, so we move I forward. 0 is not bigger than 0, we check it with the element before p, right? It's not bigger than 0, so we move forward. 1 is bigger than 0. Now p comes in the game. So what we're going to do, we are going to put the element that is bigger than the element before p in the p location, and then we move p 1 step forward, and then again we check 1 is not bigger than 1, 1 is not bigger than 1, 2 is bigger than 1. So what we are going to do, we are going to put 2 here, and we are going to move p 1 step forward, and again we are going to see if 3 is bigger than 2. It is. Then we are going to put 3 here, and we are going to move this forward, and then we are at the end of the array, and we have iterated over the array. As you see, we have all the unique elements sorted at the beginning of the array. How can we code this? So as I said, we are going to have a pointer p. So let's leave it as p, right? And it is going to point at index 1, and then we are going to have a for loop, which is going to be for pointer I, for I in range 1. As I mentioned, we are going to start from index 1 to the length of the nums. What we are going to do, we are going to check if the value that we have in I is bigger than the value that we have in p minus 1, the element before p, what we're going to do, we are going to update the value that we have in P with nums I, and we are going to move P pointer one step forward, and at the end we are going to return P, because P is like here, which shows at index 4, which shows the length of the array. So let me clean this and let's run the code. And as you see, it is accepted. So the time complexity for this is O(n). It's linear because we have to iterate over the array once, and the space complexity is constant because we are not using any extra space. Thank you.